Okay, so here we have a chapter 5 and 6 review because you have a test coming up here pretty soon. I do want you to try these problems on your own first and only use my video to check your answers and to help guide you if your own notes haven't helped you. Don't forget that we did take chapter 5 and 6 notes in a separate document in Google Classroom, so pull that up as your notes to help you through this. Treat this like a test, but then of course use this video to help guide you along. So I'm going to be going through these relatively quickly just for sake of time. So make sure that you are pausing the video throughout so you don't fall behind, okay? So number 1, it says solve for x by factoring and the zero product property. So I should say and using the zero product property. So zero product property means that my factors are equal to 0. So first let's go ahead and try to factor this. So using just the basic x diamond method. So x squared times 6 is 6x squared. That 5x is going to go on the bottom here. We have 5x. So we have to find two factors that multiply to 6 but then also add to 5. So if you want to set up all your factors of 6, we have 1 times 6 and 2 times 3. So now you want to look at those and see, okay, which of those pairs would add up to 5? In this case, it's going to be the 2 and the 3. Okay, so we know 2x times 3x is 6x squared. 2x plus 3x is 5x. So now we know that since it's factorable, we can use an area model to factor the quadratic. Okay, this x squared, it doesn't matter which corner it goes in. What really matters is that your 6, or your c term that's constant, is diagonal from that first term. Okay, so this is where x squared and 6 are going to go, and then the 2x and 3x go across from each other. These are basically the 5x split, right? We just had to figure out which way we could split that 5x in order for it to be factorable. So here, the GCF between x squared and 2x is x. Same thing between x squared and 3x. Between 2x and 6, it's 2. And then between 3 and 6, it is a positive 3. This was a positive 2. So now what we have here is 0 equals x plus 2 times x plus 3. See there, I changed the y to a 0 so we can use the zero product property. And what we're solving for are the x-intercepts. And the x-intercepts are along the x-axis. So along the x-axis, all of your y values are 0. Along this axis here, all the y values are 0. So that's why we set the y equal to 0, because we're solving for the x-intercepts. Okay, so here what we do now is we have to split these. X plus 2 equals 0, and x plus 3 equals 0. Let me make all my stuff a little bit smaller here. Looks like I'm going to run out of room. There we go. Okay, so now we just have to solve for x. Subtract 2 from both sides here. We're going to get x equals negative 2. Subtract 3 from both sides here. X equals negative 3. So your x-intercepts, or your solution, your roots, your zeros, whatever the problem calls it, they're all the same, they're x-intercepts, are negative 2, 0, and negative 3, 0. Okay, and that's your answer there. So remember to pause throughout the problems as well, because I am going faster than usual. All right, completing the square. So you guys do have step-by-step examples of completing the square. So make sure you go look at those steps. I'm going to go ahead and put this over here just so I have a little bit more room to work with. Okay, so I'm just rewriting that. So for completing the square, the first step is to move the 5, or the c term, over to the other side. Remember, please use your notes before you use this video. I want you to try all these problems on your own. So now I'm left with this, and now what we have to do is we have to add the b over 2 squared to both sides. So the 4 is our b, so we're going to add 4 over 2 squared to both sides. Now I'm just going to write this off to the side here so we can actually see what it is. So 4 over 2 squared, that's going to be 2 squared, which is 4. Okay, so this is what we're adding to both sides. We are adding 4 to both sides. We take half of the b and square it. So now we have x squared plus 4x plus 4 equals 9. And now we have to write this in x plus b over 2 squared form, the perfect square form. So our b is 4. So if we do x plus, and our b is 4, it's a positive 4, so this works out nicely. This is just x plus 2 squared. You see that? Okay, so we're going to write this perfect square as x plus 2 squared equals 9. All right, I'm going to make all this a little bit smaller. So now what we have to do is solve for x. Okay, this one, since we have the perfect square here, we can just take the square root of both sides. So if I take the square root of this side and this side, this one has to be plus or minus because we're solving for the x. So we're going to be left with x plus 2 equals plus or minus the square root of 9. Well, wait, what is the square root of 9? It's 3. Okay, that is a perfect square, so it's 3. So now what we want to do is subtract the 2 from both sides. And again, I always put that, whatever I added or subtracted, in front of the plus or minus, just so I don't forget about the plus or minus. And now at this point, we are splitting that plus or minus. So we're going to have x equals negative 2 plus 3, and x equals negative 2 minus 3. Okay, so we just split the plus or minus here and here. So now this is x equals 1, and x equals negative 5. Okay, so our x-intercepts are 1, 0, and negative 5, 0. But even if you just left your answers like this, that's full credit as long as you got the right answer. Okay? All right, now it says solve for x using the quadratic formula. Okay, so let's write out the formula here. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now in previous examples, you guys have seen me color code through these problems, so please go look at your notes for those color coding. I'm not going to color code in this video just for sake of time, but the first thing you do have to do is identify the a, b, and c. My a is here, okay, and this is because the standard form of a quadratic is ax squared plus bx plus c. All right, so my a is negative 2, my b is a positive 7, and c is negative 3. Okay, so you have to make sure that it's written in this order as well. Otherwise, you have to rewrite it, and then you can find a, b, and c. So here I have x equals negative, the b is a positive 7, and I'm going to put parentheses around anything I'm plugging in. So 7 for b, and then a is negative 2, and c is negative 3, all over, so 2 times negative 2, 2 times a. So now you just start simplifying bit by bit here. So if x equals, this here is a negative 7, plus or minus 7 squared is 49. And then what I like to do for this one is I multiply all of those together at once. Okay, so negative 4 times negative 2 is a positive 8, times negative 3 is a negative 24. And this is all over negative 4. So now this gives us negative 7 plus or minus the square root of 49 minus 24 is 25, all over negative 4. And we know the square root of 25. So the square root of 25 is 5. That is a perfect square. Whoops. So we just write 5 there. Okay, so now we're almost to the finish line. So now we have to split that plus or minus. So this plus or minus needs to be split. So we have x equals negative 7 plus 5 over negative 4. and x equals negative 7 minus 5 over negative 4. Okay? So what we did here was we just split the plus or minus that was on top there. So now we have to simplify. Negative 7 plus 5 is negative 2. Negative 2 over negative 4 it would be positive 1/2, or you could also write 0.5. Negative 7 minus 5 is negative 12 over negative 4, which is positive 3. So your two answers are 3 and 0.5, or you can write positive 1/2. All right. Okay, so here, let's go over some things about negative 1 underneath the square root sign and dealing with the imaginary I. Here's something you want to remember. I equals the square root of negative 1. I squared, on the other hand, is equal to negative 1. Because imagine this. If we did the square root of negative 1 times the square root of negative 1, that is I times I, right? That's the same thing. If I is equal to the square root of negative 1, that's just I times I. So here we could rewrite this one as the square root of negative 1 squared. I'm writing a little tiny. And then this one, I times I, is I squared. So here with the square root of negative 1 squared, the square root cancels out with the squared. So this just equals negative 1, and this is still just I squared, so I squared equals negative 1. Okay, and you can keep on going to I cubed, I to the 4th power, I to the 5th power, and so on. But really, the main ones you need to remember for right now are these two identities here. So for the square root of negative 9, you want to split up that negative 9 into the square root of 9 times the square root of negative 1. Because we have to pull out that factor of negative 1, because we know that equals I, so we can eventually replace that. So the square root of 9 is 3, and the square root of negative 1 is I. So the square root of negative 9 is 3I. Okay. Let's go ahead and look over here. So we just treat I like a variable. Okay, so we have two like terms here, 4I plus 2I. That's just 6I. And the 6 here, minus 6, that's just by itself, minus 6. So that's the answer. That's it. Some students get those confused, but you really just treat it like you're combining like terms, and then you're good to go. Okay, so let's see this one here. So we should draw an area model. Anytime you have two binomials, binomials means there's 1, 2 terms inside of the parentheses. That's a binomial. You should set up an area model. It makes it way easier for you. So here I'm going to multiply 2 minus 3I, and it doesn't matter which side they go on, just as long as one's on one side and the other's on the other side. Okay, so now if we multiply this, 4 times 2 is 8, 4 times negative 3I is negative 12I, 2 times negative 2I is negative 4I, and then negative 2I times negative 3I is a positive 6I squared. So let's simplify that. We have 8 minus 12I minus 4I plus 6I squared. Okay, so the 8 does not have any like terms as of now. Negative 12I minus 4I is just negative 16I. And then this plus 6I squared, well, we know I squared is equal to negative 1. So we need to replace the I squared with multiplying the 6 by a negative 1. So it's going to be plus 6 times negative 1, like that. So we just replaced the I squared with a negative 1. And you're multiplying it because it's 6 times I squared, so it'd be 6 times negative 1. So now here, let's see here, 8 minus 16I. Okay, so we have 8 minus 16I. Positive 6 times negative 1 is negative 6. And now we can combine 8 minus 6 because now those two are like terms. So this will be 2. 8 minus 6 is 2 minus 16I. So our final simplified answer is 2 minus 16i. That is as simple as we can go. I've seen some students try to change the I back to a square root of -1, but it's in simplest form once you have just a single I. Of course, the I squared, you would want to simplify that because we know it's equal to the integer -1. Okay, so now let's do part D. So here we have two binomials that we're multiplying together. So we have 2 plus 4i times 2 minus 4i, okay? So 2 times 2 is 4. 2 times 4i is 8i. 2 times -4i is -8i. And -4i times +4i is -16i squared. Okay, so now let's write that out to simplify it. So we have 4 plus 8i minus 8i minus 16i squared. Well, if you guys notice here, 8i minus 8i is just 0. Okay, those are 0. So we have 4 minus 16, and we know that I squared can be replaced with -1. Okay, so I squared is equal to -1. So now we have 4 minus 16 times -1. This is 4, -16 times -1 is a positive 16. So our answer is 20. Okay, so this is all about simplifying, just multiplying with area models and then simplifying your answers. Okay, this one is saying solve for x for part E. So what I like to do, of course, is draw a line down the equal sign. And I notice that this is in a perfect square form. So I can cancel out that squared by taking the square root of both sides. And we still want plus or minus here. So that squared cancels out with the squared root. So I have x plus 5 equals plus or minus the square root of -4. Let's simplify that over here. Square root of -4. Okay, so all I did was I just pulled this square root here, and we're going to simplify it. So we can split up -4 into the square root of 4 times the square root of -1. This one's nice. It's a perfect square. The square root of 4 is 2, and the square root of -1 is I. So now we have x plus 5 equals plus or minus 2i. That is what the square root of -4 is equal to. So now what we can do is subtract 5 from both sides to get the x by itself. So we're left with x equals -5 plus or minus 2i. And you could leave your answer like this, or you could also split it to x equals -5 plus 2i and x equals -5 minus 2i. But this is as far as we can go because we cannot combine the -5 and the 2i. They are not like terms, okay? But once you have just an I, we know, okay, that's an imaginary number, okay? But we know what it is. It's I. So we're going to leave it just like that. That would be your final answer. So working with the I and I squareds, it just takes a lot of practice, okay? Okay, here we have special right triangles, okay? So I'm going to go back to our notes to show you where you can find these special right triangles. So if you look in your study guide packet, you will see that we have notes on each of the special right triangles, okay? So here, if I were to take a copy of this, this is the 30, 60, 90, okay? So let's go and see here. Since this one was 30, 60, 90, I'll stick with this one for now. So this is the guide you need to use. This one's nice. It's set up the same. It's super easy there. Okay, so here, the first step is to draw a line across from your 30 degrees and label that as your x. Okay, and if the problem already has x variables being used, like if this said x instead of e, what I recommend is changing the variable either over there or here, like maybe change them all to a's if you didn't have an a in your problem, just because I don't want you to get confused if you're solving for a missing side length x and your formula uses the x variable. You still want to treat it as a different variable. Okay, so that is the smallest leg, so that's what x equals. The hypotenuse over here, this is the hypotenuse, is equal to 2x, and then your longer leg, because the x equals 9 is the smallest leg, your longer leg is x times root 3 is what e will equal. So this one's pretty straightforward. It gives us the x. Okay, so let's look a little bit closer at this. We know what x equals. So that means that d equals 2 times my x, which is 9. So this tells me that d equals 18. And they're not all going to be this easy, but this one was nice because it gave you that side length that stands by itself with no square roots or anything else being multiplied by it. So now here I know x is 9, and for the side length it's times root 3. So e is equal to 9 times root 3. So now we have all of the side lengths here. So here d equals 18 and e equals 9 times root 3. And you can always just leave them in exact form. Don't try to multiply it out to a decimal. Okay, so there's that one. So now let's look at number 6. This one is a 45, 45, 90 because if you look here, if these sides are equal, then that means these two angles are also equal because these are the angles that are across from those sides. So if this angle is already in 90 degrees, then these two must add up to 90. These bottom two must add up to 90. And if they're equal, they have to be exactly half of 90, which is 45 and 45 degrees. Okay, so I'll go show you in your notes where you can find this diagram. So if you go to the Chapter 6 study guide packet, they were the second triangle we did right here. This one's a little bit simpler because the legs are always equal. Okay. So here, whoops, that's not what I want. Whoa, no. Okay, hold on. Erase. There we go. There we go. Okay, so the sides that are across from the 45 degrees are called legs. All right, so we see here that our legs are A and B. Our legs are just equal to x, whereas the hypotenuse is x times root 2. Okay, so this is the hypotenuse. It's across from the right angle, so this here is our hypotenuse. So if we look here, this one is pretty straightforward. 8 and x are in the same place, but if you didn't see that right away, you could still set 8 times root 2, and this would be, I should have written it over here. This is how I normally write them. So 8 times root 2 equals x times root 2, according to our little formula. So here we can divide both sides by root 2 to try to get that x by itself over here. Those cancel out, and these also coincidentally cancel out. So we're left with 8 equals x. Okay, so that means that if x equals b, then b equals 8. If x equals a, then a equals 8. So for this one, it was pretty straightforward. A equals 8 and b equals 8. Now again, they're not all going to be that easy, but this one was more simple. Okay, so now we have some fractional exponents here. So I'm going to go back to our notes to show you where to find these because we did the notes on this pretty quick. Sorry, I keep yawning this morning. Okay, so let's see. Right about here. Okay, so we did quite a few notes. But what I'm going to do is I'm going to just take a copy here because this is really what will guide you through it. But there are examples here, and I will be making a video that does these as examples as well. Okay, so let's go and look at this 5-6 review. And these are the rules that we know we have to follow for exponents and roots. Okay, so here, the 81 to the 1/4 power, the top is the exponent of the 81 that will be inside the square root, and the root here is the fourth root. Okay, so we're going to rewrite this as this equals 81, and then it's to the first power of the fourth root. Okay, and all I did was follow this here. So I just used the color coding and I followed that. So the fourth root of something is basically asking you, another yawn, I'm sorry. It's basically asking you, what can you multiply by itself 4 times to get 81? So this is what you want to look for. So the fourth root of something times something times something times something, and this has to equal 81. So then you would rewrite it as the fourth root of something to the fourth power, and then the fourth power would get canceled out by that fourth root. Okay? So your calculator can totally do this for you. All right, so I like to use Desmo's calculator. So you see here we have the n and then the square root sign. You want to use that because then it will let you put a 4 there and an 81 here. And we get 3. And that is because 3 times 3 times 3 times 3 equals 81. You can also see it as 3 to the fourth power equals 81. So then if I were to do that fourth root of 3 times 3 times 3 times 3, that's just 3, right? Because that is the same as the fourth root of 3 to the fourth power, which the fourth root would cancel out the fourth power. 3 to the fourth power is the same as 81. So you can see here how that all comes together, okay? So over here, you would want to write that this would be 3 times 3 times 3 times 3, which is 3 to the fourth power. Those two cancel out, so this just equals 3. So whenever you guys have these, you actually need to simplify them completely. Okay, so it says simplify the following. So that means I need to know the answer, okay? I'm going to just block this off so you guys don't think it's part of that problem. Okay, so now for part B, I have 25 to the 1/2 power. So I know I'm going to have a square root of 25 here. Now I'm going to go and highlight. So the top one is my exponent of the 25 inside, and the bottom one is the root. So this one would be a 2 and a 1. So this is 25 to the first power, the square root of 25 to the first power. So really, guys, anytime something's to the 1/2 power, it just means take the square root of it. It's one of those invisible 1 types of scenarios where you don't have to actually write the 1 and the 2 because it's given. If it's just a blank square root, then you're taking the squared root, which is what this tells us to do here, the squared root. And something that doesn't have an exponent is assumed it's always to the first power. So here, the square root of 5, this one's a little bit simpler, okay? We could rewrite this as the square root of something times something equals the square root of that something squared, which will equal whatever that is inside. So we know 5 times 5 gives us 25. So that means the 5 squared, the square root of 5 squared, the reason why this equals 5 is because the squared cancels out with the square root. So this equals 5. And you all already knew that. Square root of 25 is 5. But this is why it is 5. Okay? So now this one does not say simplify. It says rewrite each radical below as an equivalent expression using fractional exponents. Okay? So this note here, yeah, let's do this and then let's see. There we go. Whoops. Oh, that's weird. Okay, never mind. It came with the 3. Okay, let's just leave it like that. Okay, so here it just says rewrite each radical below as an equivalent expression using fractional exponents. So now we are going from here to here. All right. So here I have the cubed root of 9. So that cubed is the n. And since there's no exponent, it's just a 1 here. Okay. That's that invisible 1. So now we can rewrite it. So 9 is our base, or like our x here. And then it's going to be raised to the 1/3 power. So that is with the 1 on top and the 3 on the bottom. Okay, so anything raised to the 1/3 power is just the cubed root of that number. So that is our simplification as an equivalent expression using fractional exponents. Okay, so now here we do the same thing. This n is the root, so this is the cubed root of 10 to the 4th power. So we want to rewrite it using fractional exponents. So now this is going to be the base 10, and we have the x, whoops, we're going to have the, oops, gosh, sorry guys. So the root will be on the bottom, and the exponent will be on top. Okay, so again, I'm just using this little key right here. So 10 to the 4/3 power, 4/3. All right, so this is a fractional exponent right there. So I hope that this video helped you and that you were able to complete some of these on your own, hopefully.